Good evening, dear students. So, in the last class, we have started with the physical chemistry chapter, that is chemical kinetics, right? So, in the last class, we have solved some MCQs. Okay, so the same chapter we are going to continue in the today's class. I think we have solved some 12 questions, right? So, we have solved the questions on first order half-life, right? Then, yes, half-life period, right? Arrhenius factor. Yes, okay. Uh, so these questions, okay, energy of activation. So based on these concepts, we have solved some questions. So, so let us continue. Okay, I think we have solved till 12th. Yes. So let us start from the 13th question. Okay, 13th question. So the 13th question is here. So A, okay, which is gaseous, A is a substance which is gaseous in state. It is heated to give you P, okay, plus Q plus R. Okay, so these are the products obtained. These are all gaseous again. These reaction, it follows the first order kinetics, okay, and the half life is given half life of 69.3 seconds at 500 degrees Celsius. Okay, starting from the gas A enclosed in a container at 500 degree and at a pressure of 0.4 atm, the total pressure of the system after 230 second will be. So you have to find out the total pressure, okay, after the system, that is after 230 seconds. So these are the four options: A 1.15 atm, B 1.32 atm, C 1.22 atm, C 1.12 atm. Okay, so how we are going to solve this? How we are going to solve this particular question? So what they have given, a reaction is given. Okay, A is a substance which on heating will give you the products B, P, Q, and R. Okay, and it follows what? It follows the first order kinetics. It follows what? It follows first order kinetics. Okay, and their half life is given, which is 69.3 at a temperature of 500 degrees Celsius. Okay, so so E is a gas which is enclosed in the container at 500 degree Celsius and a pressure of 0.4 atm. Okay, so from the gas A, okay, so after so what will be the total pressure after 230 seconds? Yes, how we are going to solve this? So what all things are given that you have to mention first. Okay, so let us see what all things we have mentioned here. So first one is the T half, right? First one is what? T half is given. T half is, that is half life is 69.3 second. Okay. And after T, after the time T, that is T is given. Okay, that is 230 seconds. Okay. And the atmospheric pressure is given, which is 0.4 atm. Okay. So what you have to find out? So this is a first order kinetics. So according to first order kinetics, what is the rate equation? It is 0.693 by T half, right? So you're finding out the T half, okay, half life T half of this reaction. So T half is equals to 0.693 by T half. So we have what? We have the, we have to calculate the rate, okay, K. So here, what do we need? We have T half we have. So after solving this, so 693 by T half is 69.3 seconds. So how much you're going to get? Just see how much you're going to get. So we have to find the value of K. So 69.3. So it will be 0.01 per second, right? 0.01 per second. Now, using the first order kinetics equation, so K is equals to 2.303 by T log of A by A minus X. Okay. So that is 2.303. What is the time taken after? So we have to calculate at the time of 230 seconds. So 230 second. Okay. So log of, okay, what is the atmospheric pressure at a pressure of, so that is 0.1 initially, and after 230 second we don't know. So let me put it as 0.4 minus X. Okay. 0. 4 minus x. So solve this, solve this. What you're going to get? What you're going to get? So we have k now, right? We have k. We have got k from the above equation, that is from the T half. Okay, from the half-life reaction, we have got k. K is 0.01. Okay, 0.01 is equals to 2.303 by 230. Okay, log of 0.4 by 0.4 minus x. Okay, so what we will do now? So this will be 0.01. Okay, so 230. So this will be how much? So 2.303, calculate 2.303 divided by 230. It will be 0.01. Okay, so it will be 0.01. So 0.01 into log of, okay, 0.01 into log of 0.4 by 0.4 minus x. So, so 0.01 is equals to, so if you transfer this 0.01, okay, how much it will be? 0.01 by 0.01, okay, which is equal to log of 0.4 by 0.4 minus x. This 0.01 is a k value, okay, and this 0.01, okay, what we have got, so this is the k value, and this 0.01 is what, which we got for 2.303 by 230. Okay, so how much? So after what is that? 0.01 divided by 0.01 will be 1. Okay, so 1 will be equal to, so 1 will be equal to log of 0.4 by 0.4 by x. Okay. So so this log, if we transfer here, it will be anti-log. Okay. It will be anti-log. So take anti-log on the other side. So anti-log of 1 is equals to 0.4 by 0.4 minus x. Okay. So anti-log of 1 is what? It is 10. Okay. Antilog of 1 is what? It is 10. Antilog. Understood up to here? Are these steps clear up to here? Any doubts? Any doubts up to here? Is it clear? What all things? Okay. Okay. Fine. Again, I will explain here. So what they have asked, I hope the question is clear. Okay. So what we have done first we have find out the half-life. Okay. Half-life of the this. Okay. K. So K is equals to 0.693 by T half. So T half we have 69.3. So after getting that, we have got the K. Okay. Now from the first order kinetics, okay, the formula is K is equals to 2.303 by T log of A by A minus X. Okay, so solve this. So 2.303 by time is given, that is 230 log of 0.4, okay, upon 0.4 minus x. So just we are solving that. After solving, okay, that is k is what? 0.01. Okay, and what is 2.303 by 230? That is also 0.01. So log of 0.4 upon 0.4 minus x. So what we have done here, we have transferred this 0.01 from right hand side to the left hand side. Okay, we got this particular step. Then that is equals to log of 0.4, rest all will remain same. So 0.1 by 0.1 is 1. Okay, and here we have log. So log, if we transfer this side, it will be anti-log. So anti-log of 0.4 divided by 0.4 minus x. So what is anti-log of 1? That is 10. Okay, anti-log of 1 is 10. So 10 is equals to, okay, 0.4 by 0.4 minus x. Okay. So that will be, so just what you have to do, multiply this, okay, cross multiply. So x will be what? Just see what x will be. What will be your x? So 0. Okay, so answer. Okay, x I'm getting it as 0.36. Okay, x I'm getting as 0.36. Now for this reaction, A is equals to, when you heat, giving you P, okay, plus Q plus R. So initially, okay, what is initial? Initial is 0.4. Okay, initial is 0.4. So subtract 0.4. Okay, final will be 0.4 minus 0.36. Okay, so this is the final. So at P, Q, and R. Okay, so after a time, so 0.36, 0.36, and 0.36. Okay, so when 0.4, okay, so first the pressure applied at A was 0.4. Okay, so after it is heated, it is giving the product P, Q, and okay, so you are getting 0.36, 0.36, and 0.36. Now subtract 0.4 minus 0.36 plus 3 times your this. Okay, so just see here. So what I'm getting, so 0.4 minus 0.36. Okay, because what you are applying, pressure is of 0.4. So subtract, so after heating, you are getting the pressure as 0.36. So minus, okay, plus how many so the products are 3, so at every product the pressure applied is 0.36, so 3 into 0.36. Okay, so calculate now, calculate. So 0.4 minus 0.36 is 0.04 plus 3 into 0.36 is 1.12. Okay, 1.12 ATM. So option number C, sorry, D. Option number D. Okay, I'm getting option number D as the answer. Okay, option number D is the answer. So what they have asked, so for the starting reactant, okay, the pressure and the temperature, pressure and this is constant. Okay, so at a that is at a gas A, it is enclosed in a container at 500 degrees Celsius. Okay, to that they have applied a pressure of 0.4 atm. So what they have asked, the total pressure which is applied on the system. So the total pressure applied is 1.12 atm. Okay, so this is the answer. Okay. Next question, 100 cm cube of 1 molar acetic acid was mixed with 100 cm cube of 2 molar methanol to form an ester. The change in the initial rate if each solution is diluted with equal volume of water would be A 4 times, B 0.25 times, C 2 times, and D 0.5 times. So what is the question? So what is the question? Again, I'll read. 100 cm cube of 1 molar acetic acid was mixed with 100 cm cube of 2 molar methanol. Okay. So acetic acid was mixed with methanol. Okay. Acetic acid was mixed with what? Just a second. Okay. Can you see the screen now? Okay, fine. Now just see here. Okay. So what we are discussing here, So the okay, so what is happening here? Methanol. Okay, methanol is there. Okay, it is mixed with what? It is acetic acid is mixed with your methanol. So when methanol acetic acid is mixed with methanol, so your acetic acid was 1 molar and your methanol was 2 molar. Okay, what is the question? What is the question? Again, I'll read it here. 100 cm cube of 1 molar acetic acid was mixed with 100 cm cube. Okay, so this both are 100 cm cube. Okay, to methanol to form an ester. So which is the ester which is formed? It is methyl ester, right? CHC, C double bond O, CH3. Okay, so dimethyl ester plus water is formed. So what they have asked, what they have asked? The change in the initial rate if each solution is diluted with equal volume of water would be. So what will be the this? Okay, so what will be the initial state? So the change in the initial rate if each solution is diluted with equal volume of water would be A 4 times, B 0.25 times, C 2 times, and D 0.5 times. Okay, D 0.5 times. Now here, what we are seeing? So rate, okay, rate is equals to K into so acid of acetic acid into of methanol. So what is the rate of acetic acid is 1 and that of the concentration of methanol is 2. So what it is? So is equals to 2K. Okay, it is 2K. So when the solution is diluted, what they have asked when you dilute it, okay, so you have to reduce it to half, right? When the change in the initial rate if each solution is diluted with equal volume of water would be. So what you are doing now? So find out. So when the solution is diluted, okay, with equal volume of water, concentration is what will happen to concentration? Concentration also will become, it will reduce. Okay, so rate R2 will be equal to K into, okay, 1 by half and this is 2 by 2. Okay, so what we are doing? We are diluting. After diluting, what will happen to concentration? The concentration will be reduced. So divided by 2. So 1 is a concentration of acetic acid, 2 is the concentration of your what? 2 is the concentration of your methanol. So what you are going to get? So now what you do? Substitute R1 and R2. So therefore R1 by R2, okay, is equals to what is R1 is 2K and R2 is equals to what is 2 by 1. Okay, it will be K by 2. Okay, this is 1 and this is K by 2. So this is 1 and this is K by 2. So how much you are going to get? So this K and K will get cancelled and it will become what? 4. So R2 will be R1 by 4. Okay. So R2 will be R1 by 4. So 1 by 4 is what? 1 by 4 is 0. So R2 is equals to 0.25 into R1. Okay. So let us see. Understood up to here? Is it clear? Okay. So okay. See here. Okay. So here we were, so answer is what? 0.25 times. So it is option number, which one? Option number B, right? Option number B. Understood? Is it clear? So what they've asked, so when you mix your acid with your alcohol, you are going to get a ester. Okay. So what they have done, whatever the initial rate is there. So rate, so initial rate we have found out, right? R1 is equals to K of, that is rate of acetic acid into rate of methanol. So what is the rate of acetic acid is 1, okay, and that of your methanol is 2. So that is 2K. Then same way with respect to 2, okay, when you add equal amount of water, okay, what will happen? What will happen when you add equal amount of water? It will get diluted. So what I'm doing, rate is equals to 1 by 2 and 2 by 2. Okay, so find the rate when you get diluted. So this will be 1. So it will be K by 2. So now substitute R1 by R2. So that will be 2K by K by 2. So K will get cancelled. So R1 is equals to what is R1? R2 will be equal to what? R2 will be equal to R1 by 4. Okay, R1 by 4. So K by 2. So that will be equal to 4. So R2 will be equal to R1 by 4. Okay. So R1, R2 will be equal to 0 0.025, 0. After solving 1 divided by 4 is how much? It will be 0.25. Okay, so 0.25 times of R1. So our answer is option number B. Okay, I hope it is clear. Fine. So just you need to know. Okay, so stepwise you have to follow the question. Okay, so reading the question is you have to read the question properly. Fine. Next question. In a first order reaction, the concentration of the reactant is reduced to 12.5% in 1 hour. When was it half completed? So A 20 minutes, B 15 minutes, C 3 hours, and D 30 minutes. So in a first order reaction, the concentration of reactant was reduced to 12.5%. Okay, in 1 hour. So when was it half completed? So you have to tell the half life. Okay, so how we are going to solve this? So this is a for a first order reaction. Okay, so for considering the first order reaction, so K will be equal to what? K will be equal to 2.303 by T. Okay, log of concentration of A naught by concentration of A. Okay, so substitute. So 2.303. Okay, time. So half. Okay, the concentration of the reactant is reduced to 12.5% in 1 hour. 1 hour means nothing but 60 minutes. So 60. Okay, time is given. 1 hour means 60 minutes. Okay, 1 hour is 60 minutes. So log of. Okay, log of. So the final concentration is 100, and this is how much? 100 minus this will be sorry, so it will be 12.5. Okay, so it is reduced to 12.5. So calculate, find out this, find out 2.303 divided by 60. Okay, so that is 0.0383. Okay, and find out 100 by 12.5 is 8. Okay, and log of 8 is how much? Log of 8 is 0.90. So find out now. Simple calculation. So 0.9 into 0.0383. So I have got the answer as 0.0346 per minute. So this is the K, okay, rate constant for first order reaction. Now they have asked the half, okay, how much? T half. So T half is equals to 0.693 divided by K. So 0.693 divided by K is 0.0346. Find out how much you're getting. 0.693 divided by 0.0346. 20 minutes. So for when you reduce, okay, it was half completed in 20 minutes. So option number A. Option number A. So in a first order kinetics, the concentration of the reactant is reduced to 12.5% in 1 hour. So time is given. Okay, initial concentration we know. This we know. Okay, 100 divided by 12.5. Okay, after substituting, we got the rate constant also. Then we have to find the T half of the reaction. So rate constant we know. So after substituting, we are going to get 20 minutes. Okay. So option number A. Is it clear? Is it clear? Okay. So very important. Okay. First order reaction and half-life questions on these are very important. Half-life period of a first order reaction is 10 minutes. Okay. Half-life period of a first order reaction is 10 minutes. Starting with initial concentration 12 molar, the rate after 20 minutes is. So what is the rate after 20 minutes they have asked. So initial concentration is what? 12 molar. Okay. The initial concentration is how much? It is 12 molar. So initial concentration is 12 molar. Okay, 12 molar. Okay, so this is your initial concentration. So after uh, initial concentration 12 the rate after 20 minutes. Okay. So after t half. Okay. After half minutes. How much it will be? What is the half of 12? It will be 6 molar. Okay. Again, after half time. Okay. After the half, what is the half period of 6? It will be again 3 molar. Okay. So T half is how much? T half is given as 10 minutes. So T half is 10 minutes. T half is 10 minutes. Now if you calculate the K, that is 0.693 by 10 minutes. Okay. So how much it will be? It will be 0.0693 per minute. Okay. Per minute. Okay. So as the T half is how much? The T half is given as 10 minutes. Okay. So after 20 minutes, what will be the concentration after 20 minutes? So this is 10 minutes. So 10 into, so after 10 minutes, so after 20 minutes, so 10 and this 10. So it will be 20. So it will be 3 molar, right? It will be 3 molar. So rate will be equal to how much? So 0.0693 into 3 molar. Okay, into 3 molar. So how much it is calculate? 0.0693 into 3 molar per minute. Okay, so answer is our 0.0693. Option number D. Option number D. Understood? So initial concentration is 12 molar. So they have given the T half. So T half, after T half, how much molar it is converted into half. So it will be 6 molar. So again, if you apply the half life period, it will be 3 molar. So the half life is given as 10 minutes. So for completion of 10 minutes, it has the initial concentration has reached 6 molar. So again, from 6 molar after half, that is a half life period, okay, the initial concentration has reached how much? 3 molar. So the rate after 20 minutes will be how much? It will be 0.0693 into 3 molar per minute. Okay. So option number D is the answer. So again, so like this, the questions, you can see the pattern of questions are different, okay, based on the half-life first order. So the pattern of asking the questions are quite different. Next one, the half-life period of a first order reaction is 60 minutes. What percentage will be left over about 240 minutes? The half-life period of a first order reaction is 60 minutes. What percentage will be left over after 240 minutes? A 6.25%, B 4.25%, C 5%, and D 6%. The half-life period of a first order reaction. So T half is given. T half is how much? It is 60 minutes. Okay. What percentage will be left after 240 minutes? So first calculate the T half. Okay, T half, how to calculate T half? T half is equals to 0.693 by K. So K is equals to, how much it will be? 0.693 by T half is 60. Okay, how much it is? Calculate. The K will be 0.693 divided by 60 is how much? 0.693 divided by 60. 0.01155. Okay, 0.01155. Okay, now this is per minute. Okay, this is per minute. Now put the your first order this. Okay, so what percentage will be left after? So K is equals to, okay, so K is equals to, okay, K is equals to 2.303 by T log of A by A minus X. Okay, so let the initial concentration, okay, if we consider as 100. Okay, so K we know, so that is 0.01155 is equals to 2.303. Okay, for we have to calculate for 240 minutes. So 240 log of, if we consider initial as 100, okay, so your this will be A minus X, right? So substitute. So if I, what I can do, 2.303 divided by 240. So just transfer this here. Okay, after rearranging, this goes here. So this will become 0.01155 into 240. Okay, and this will get divided as 2.303. Okay, so log of 100 by a minus x. Find out. So 0.01155 into 40 is 0.462 divided by 2.303 is 0. Into 240 divided by, so it will be 1 point, I have got it as 1.203. Okay, after solving this 0.01155 into 240 divided by 2.303, I got it as 1.203. Okay, is equals to, into log of 100 by a minus x. Is it clear up to here? Are the steps clear up to here? Yes. Are the steps clear up to here? Okay. See here, just now, whatever I have showed you. So T half is equals to 0.693 divided by K. Okay. What was given? T half was given. So 0.693 by T half is 60. That we have got it as 0. K. Okay. So K. Okay, so what I have got 0.1155. Okay, 0.01155 per minute. So this I have got it as K. Okay, this is our K. Okay, from this your half-life. Okay, now K is equals to what? 2.303 by T log of initial concentration minus A minus X. Okay, so if we consider the initial concentration as, if we consider the initial concentration as 100, so put it, so K is equals to 2. Okay, we have K also, we have K, so let us put the value of K. What is K? K is equals to 0.01155. Okay, 0.01155 is equals to 2.303 by T. T is, now we have to calculate what at 240 seconds. Okay, at 240 seconds. So what percentage will be left over after 420 minutes? Okay, so A is equals to 100 log of 100 by A minus X. So what we will do, we'll transfer this here. So 0.01155 into 240 divided by 2.303 is equals to log of 100 by A minus X. So this, okay, this after solving, I have got it as 1.204. Okay, I have got it as 1.204. That is equals to log of 100 minus log of A minus X. Okay, log of 100 minus log of A minus X. So after that, what I am going to get? So log of 100 is how much? Log of 100. How much is log of 100? Calculate. Log of 100 is 2. Okay, log of 100 is 2. Log of 100. I'll write it this step again here. Okay, so 1.204 is equals to log of 100 minus log of a minus x. Okay, whenever we divide log by 100 minus a minus x, it will be what? It will be subtract. Okay, so log of 100 minus log of a minus x. So 1.204 is equals to log of 100 is 2. So 2 minus log of a minus x. Okay, log of a minus x. Okay, so log of a minus x. So now, so log of a minus x is equals to 2 minus 1.204. So how much it will be? 2 minus, just resubstituting. Okay, so we will solve. So 0.796. 0.796 is log of a minus x. Okay, so or x is equals to, okay, so log, so what we will do? So we will transfer log that side. Okay, so I'm going to get what? So or a minus x, okay, will be equal to, so ln of 0.596. So a minus x, okay, it will be 6.25%. So it will be 6.27%. 0.796. Not able to see. Okay, fine. Okay, so it is 6.25%. Okay, it is 6.25%. So after solving, we have got it as 6.25%. So just a simple substitution. Okay, and we are going to get this particular answer. Okay. See 19th one, 19th question. 19th question. 3a giving you 2b, rate of reaction plus d by d of b, okay, concentration of d by dt is equal to. So how you are going to write this? You have to write the rate of concentration. Okay, so 3a giving you 3b, rate of reaction, that is plus concentration of b by dt is equal to. So how you are going to answer? So these are the four options what they have given. So if I write the rate of this equation, okay, so it will be what? Minus 1 by 3 d of concentration of A by dt, okay, which is equal to plus 1 by 2 d of concentration of d by dt. Okay, so minus, so if I write this minus 2 by 3 d of A by dt is equals to plus d of b by dt. So it is minus 2 by 3. So it is option number B. Okay, option number B. Got it? Did you get it? Right. So they are asking what is plus d concentration of dB by dt. So what we have done, we have transferred this to this side. Okay. So 2 by 3 d of concentration A by dt is equals to 3 d of concentration of B by dt. So the value is minus 2 by 3. Okay. Minus 2 by 3. Okay. Can you see this now? Yes. Okay. So let us move further. The activation energy of a chemical reaction can be determined by, how does the activation energy of a chemical reaction can be determined? evaluating the rate constants at two different temperature. B, changing the concentration of reactant. C, evaluating the concentration of reactant at two different temperature. And D, evaluating the rate constant at standard temperature. Yes. So how does the activation energy? So we know that activation energy, okay, log of K2 by K1, okay, when we evaluate the two rate constant, okay, EA will be equal to 2.303 R, okay, T2 minus T1 by T1, T2, right? So what is the answer? This is the activation energy. So if you evaluate the rate constant at two different temperature, okay, activation energy of a chemical reaction can be determined. What is activation energy? EA. So how it can be determined? By evaluating the two rate constants, okay, at two different temperature. Is it clear up to here? Yes, is it clear? Yes, Shivaruni has answered it correct. Very good. Okay. Okay, 22 question. Read the 22 question. Which of the following statement in accordance to which of the following statements in accordance with the Arrhenius equation? Which of the following statement is in accordance with the Arrhenius equation? A, rate of the reaction increases with increase in temperature. B, rate of the reaction does not increases with activation energy. Rate constant decreases exponentially with increase in temperature. D, rate of the reaction increases with decrease in activation energy. How you are going to describe this? What is Arrhenius equation? Arrhenius equation is given as K is equals to AE minus EA by RT. Right. So on increasing temperature, so as the temperature increases, okay, what will happen to the activation energy? It will decrease. And what will happen to the rate of a reaction? It will increase. Okay. So rate of the reaction increases with activation energy. A is answer. Then also what do we say that this rate of the reaction increases, rate of the reaction increases and your activation energy will decrease. So option number A and D both are correct. Okay, if you write any one also, if you tick any one also, it will be correct. Okay, if such questions are there, okay, where two options are there, so any one of this if you tick, then your answer will be correct. Okay, so both, they will give you grace mark for this. So both A and D are the right answer. Okay. Next question. Which of the following statement is incorrect? Molecularity is only applicable for elementary reaction. B, the rate law for any experimentally, the rate law for any reaction, okay, cannot be determined experimentally. The rate law for any reaction cannot be determined experimentally. See, biomolecular reactions involve stimulus collisions between two species. D, complex reactions have fractional order. What is the answer? Yes. What is the answer? Which is incorrect, they asked. Which is incorrect? Which is incorrect? So whenever you are discussing about the rate law, okay, the rate law for any reaction, it cannot be determined theoretically, but it can be what? It can be determined experimentally. So option number B. Okay, what they have given, option number B. Okay, the rate law for any reaction cannot be determined experimentally. Okay, but the correct statement is that the rate law for any reaction cannot be determined theoretically, but it is what? It is done experimentally only. Okay, is it clear? Okay, so yes, so these were some of the questions. Okay, fine. Some more questions will do. The value of rate constant of pseudo first order reaction. The value of rate constant of pseudo first order reaction depends only on temperature. B, depends on the concentration of reactants present in small amounts. C, depends on the concentration of reactants present in excess. D, is independent of the concentration of reactant. How you are going to answer this? So theoretical questions. Okay. So pseudo first order reaction. What are pseudo first order reaction, students? What are pseudo first order reaction? So pseudo first order reaction means what? They are second order reaction. Okay, pseudo first order reaction. It is a second order reaction, but they behave like a first order reaction. Okay. Why? Because one of the reactant will be in excess, right? Okay. So on what basis it depends? So it depends on the temperature. Okay. Remember that the value of the rate constant of pseudo first order reaction, it depends on the temperature. Yes. Option number A. Yes. Kavya has answered. Shri Varuni has answered. Okay. Fine. Fine. So these were some of the questions from the chapter chemical kinetics. So most of the questions we have tried to solve. Okay. Mm, yes. So this completes your syllabus. Okay. Your PU2 syllabus. So all the chapters have been completed from your PU2. Okay. Based on the, so all the, so what are the type of questions? Okay. So all the particular type of questions are solved. Fine. Okay, so in the next class, we will be solving some model paper. Okay, we'll be solving some model paper. Is it clear? Okay. Any doubts up to here? Any doubts? Okay, fine. So thank you. Okay. So I'll end this session here. Okay. In the next class, we'll be solving some questions. Okay. From the all the chapters. Okay. I'll take mixed questions from all the chapter like a model question paper. Okay, fine. So thank you, dear students. We'll end this session here. We'll meet in the next class.